Broadcast is now starting. All attendees are in listen-only mode.
All right. Good evening, everyone. Welcome to our snow measurement training course. Uh, Thanks for joining. I know many of us have snow on the ground already, but this is a really good refresher on learning how to measure it accurately and something we can remember all through the winter season. So thanks again. My name is Robin Fox. I'm at the National Weather Service office in Spokane, and we're going to go through the next hour or so talking about proper ways of measuring snow and more about the CoCoRaHS program, which is short for the Community Collaborative Rain, Hail, and Snow Network. So we're going to get a lot more into that as we go through our presentation. And hopefully you are able to hear me good. And if you have any questions, we do have a chat system. So just to let you know, this is a live virtual class. And I know we've gone through a lot of these virtual things over the last couple of years. So just a refresher, you don't need to call in. This is voice and computer, and headphones are really useful. We're going to have a chat system available, so feel free to put your questions in, but let me let you know that probably won't get to answer them till toward the end of the class. And at the end, I'm also going to unmute everybody and give you a chance to ask them to me right on the class. So just feel free to hang on to those as well. As for other information, I don't have any handouts for this class, but after we're done, I'll be emailing all of you and getting you all set up with links and notes and everything from this class. So no need to get concerned about finding any handouts, but I'll send you those afterwards. Okay, so the objectives for this class is pretty easy. We're going to talk about the importance of observers, those that measure precipitation, rain, hail, and snow. And we're going to talk about how to take them accurately. Rain is pretty easy. Snow has a lot more steps. So this is a good time to review all of this so we're ready as we go through our busy next several months. We're also going to talk about how to prepare, how to be safe for the winter weather. And then, yes, you're going to get a sneak peek, the winter outlook for 2022 to 2023. But first, let's look back at what happened last year. If you forgot for any reason, or maybe you're new to the area and you're not quite sure. Yes, we had our bout of heavy snow. Just last year, over the holiday period, we had some heavy snow. And that can really affect travel, especially across the mountain passes. And in fact, that was December 30th, I believe. All of the Washington passes in the Cascades were closed for some period. So we know Washington Pass, that closes once it gets snow and it's not open again, and that's on Highway 20. But Highway 2 at Stevens Pass, Snoqualmie on I-90 is the big one, and then there's White Pass as well. And all of them were closed during this period in December 30th when we had heavy snow. And that heavy snow even stretched across inland Northwest, even to the LC Valley, where they got some significant snow as well. Now, if we also remember getting into early January, we had another round of heavy snow, and this was more in the frame of 1 to 2 feet of snow, especially for up in Boundary County by Moyie Springs and Elmira, but also in Okanogan County as well, where Tenasket got 21 inches of snow. And then even in Quincy, which is in Grant County, got just over a foot of snow with that. So there was a lot of shoveling going on, even to get to the rain gauges as well. And then in April, we had the heavy snow that affected the Wenatchee area. We had some really unstable conditions that led to intense snowfall that happened, where we saw 8 to 16 inches of snow just in East Wenatchee. So that was very significant. So, to all of you that are current observers, thank you so much. We appreciate all your reports, and we know measuring snow is a challenge and it takes some work. I myself am a observer and measure snow on a daily basis, so I understand that it can be tricky at times. But for those of you that are new to the program, let me give you a little overview of what it is. CoCoRaHS, CoCoRaHS. It means the Community Collaborative Rain, Hail, and Snow Network. And it is a nonprofit organization that is a partner with the National Weather Service. It's based out of Fort Collins, Colorado, and they manage sites all across the United States and Canada and other parts of North America. And it began back in 2008. So we're going on 14 plus years ago. So it's a community-based network of measuring precipitation, and it's made up of volunteers of all backgrounds. People who are interested in the weather, interested in precipitation measurements, and are dedicated to give us daily reports on that. So, more about the National Weather Service, NWS. Okay, we are part of the federal government under the Department of Commerce, part of NOAA, the National Oceanic and Atmospheric Administration. So, the National Weather Service, they are the behind the scenes group that does the weather forecast all across the country and the inland Northwest. And the Spokane office is the one that's in charge of the inland Northwest. But the main mission of the National Weather Service is to provide the weather and water watches and warnings in order for protection of life and property. So when the severe weather happens, when the big snowstorm comes, the watches and warnings come out from the National Weather Service to let you know what's going to be happening. So we work with other agencies, the Forest Service, the DOT, many other agencies in the area to get the word out on impending hazardous weather. We also provide decision support for a lot of the big events that are going on, and also for any of the big wildfires in the area as well. And we also work with preparedness and education, so everybody knows how to be safe when the weather turns nasty. So with the National Weather Service, we have offices all across the country. In fact, there are 126 offices, and Spokane is just one of them. And our area, the inland Northwest, is so diverse. We have mountains in the Cascades that are well over 9,000 feet. And then we have elevations along the Columbia Basin near the Columbia River that are maybe 170 feet above sea level. So quite a range. And the weather can be quite diverse as well, with snow and rain and wind and dryness as well with the downslope events. So we have 13 counties in Washington, all east of the Cascade Crest, and then 8 counties in North Idaho. That's in the Idaho Panhandle. So the National Weather Service has lots of tools that we use to monitor the weather and take weather observations. And the main ones I want to talk about are the ones that we use quite a bit to assess the atmosphere and find out what kind of precipitation is falling. One of the main tools is our Doppler weather radar. And that is located right outside our office, which is on Rambo Road on the West Plains west of Spokane. Looks like a giant soccer ball on stilts. But inside this ball, we have a giant dish that's rotating and scanning the skies and looking for precipitation. And actually, it has algorithms in there to let us know what type of precipitation it's seeing as it's looking through the atmosphere, not only horizontally but vertically, but getting us an assessment: is it rain, is it snow, or is it hail? And giving us the intensity of that. That is the reflectivity that shows up with the different colors on the radar screen. Also, with Doppler weather radar, it can detect velocity. where the motion is either coming toward the radar or away from the radar. And that gives us a good idea of wind speeds within a storm and also rotation when we're looking for severe weather within the thunderstorms. Another important tool is the weather balloon. So at our office, we launch weather balloons twice a day, every day, right from Rambo Road. And we fill up a giant hydrogen balloon that stands about 6 feet tall on the ground. And we have a long string, and then we tie it to this little instrument right here that is called the radiosonde. And in that little box, we have a lot of weather tools, including a thermometer, uh, a barometer, uh, a device to measure the humidity, and also GPS to let us get an idea on the wind speed and direction so we can track it as it goes through the atmosphere. So we tie that little box to the string and then just let it all go. And it rises through the atmosphere and gathers all that information, sending it to a computer in the office. So we're getting data every second coming from that weather balloon. And as that balloon is rising through the atmosphere, it continues to send that data. And that flight time takes about an hour and a half, hour to 45 minutes until it reaches the edge of space. And when that happens, that balloon has expanded so big that it will finally burst. And then all of that will come back down to the ground and the flight is terminated. So these balloons rise up about 10, 15 miles high, and pressure wise, we get up to 5 millibars high. Another important tool that we use are weather satellites, and more specifically, geostationary satellites that we use a lot. They're called GOES, which means they are a satellite that's fixed over a position of the Earth. And the one that we use is positioned over the Pacific Ocean. It's known as GOES 17. So it gives us a good view of the storms that are tracking across the Pacific because our weather is coming from the west and moving to the east and reaching the coast and then moving inland. So we can get a good idea what's happening in the over the Pacific to know what weather is going to impact us. But with these weather satellites, we are able to look at the clouds from space. Think of the satellite as a giant camera that's up looking down on the Earth. So we can see the clouds, we can see the storms, but it also gives us different channels to look at, including water vapor, knowing where that tap of moisture is to feed the storms. Also temperatures. IR is really important. So we know the temperatures of the clouds. And we get this satellite data so frequently, almost every 5 minutes, that it helps us get a handle on a storm development with thunderstorms, letting us know where there's fog developing in the valleys, and with wildfires as well. We can see the smoke plumes popping up when fires do start. So it's a very handy tool. Other tools that we use are just our surface observations. We have many sites that provide us weather information on the ground. Our airports have the automated surface observing stations that give us round-the-clock weather information, whether it's temperature, humidity, cloud cover, winds, pressure. And all of that information is very important for pilots. That's why we have them at our airports. But we also have other weather sites along highways, thanks to the DOT, and weather sites also up in the mountains and in the forests, thanks to the Forest Service. So we can have a good idea what's going on at the ground level across our area. And also we have a network of web cameras that we're able to use as well, primarily from the DOT, that gives us an idea of what the precipitation is falling at, so we can see where there's rain versus snow or a mix. And that also provides important information for us to refine our forecasts and our warnings as well. Another important tool is our weather models, especially the high resolution ones. We use a lot of computer data to be able to run these computer models that forecast the weather. And we can get some updated, frequently done precipitation amounts, weather forecasts that will give us updates every hour on different types of models and ideas of what is going to be happening with the weather. So we have lots of different solutions, a lot of information to look at to help us refine our forecasts. So with all these tools, why do we need observers? Well, it's really important. We do have limitations with some of our tools, especially with the radar. Sometimes we can't see at distant locations. With the satellite, sometimes we need more refined information of where it's raining or snowing. And we like to have ground truth. What is happening on the ground? So we may be able to see things from our radar and satellite, but knowing what's happening at ground level is so important. It also helps us fill in the holes that we can't see with our observations. So it's very important to get some of that data in some of our more rural locations. And also we have a lot of microclimates, and we understand that how the weather can be different when you go from one ridge line to another or one valley to another. They all have their own unique features to that. And we want to get the best data so we can maximize our warning effectiveness and get the message out and be as accurate as we can. So that also helps with our credibility with the National Weather Service warnings. So who else would be using rain and snow observations? Well, there's so many different people that are interested in that. Not only weather forecasters, hydrologists do, water management does, researchers, agriculture, climatologists, the insurance agency is very interested as well, recreation, and so many more. So precipitation observations are so important and are used in many different fields. So if you are currently a CoCoRaHS observer, you probably know how to do this. Very easy to report. And those that are new to the program, yes, you can go check it out as well. Just go online to CoCoRaHS.org and you get to the website. And what I really like about it is you get this map that shows up that shows the current precipitation reports all across the country and North America. And I find it fascinating to see where we had the heaviest rainfall across the country. So this is one that I just pulled in today, and you can see we had so much precipitation that fell in Maine and parts of New England. So that's really fascinating to see. Also, with CoCoRaHS, volunteers can also transmit this online. There is an app that you can use, and I use quite frequently as well to get my report in when I can't be at the computer to do that. So here is a precipitation map that was taken, this is November 7th. So this is when we had our big round of precipitation just a week ago. So this was liquid precipitation, and we can see all these reports that were in Western Oregon and Northern California and even parts of Western Washington as well, where we were seeing well over an inch and multiple inches of precipitation. And if we kind of look back in like a year ago, over Christmas time last year, we can see some of the snowfall reports as well that happened. So you can switch it from precipitation to snowfall and be able to see some areas that really stood out of 9 to 16 inches of snow that fell across parts of the inland Northwest. So that's pretty fun to see as well. Also with CoCoRaHS, we're able to take measurements on drought conditions, and we know we've been there. It's been dry at some time, especially last year, and this year not as much, but still we're able to get ground measurements on what's happening with drought, especially from the observers. So CoCoRaHS is able to do that as well. And there's lots of resources that we have available that you can learn more about with the CoCoRaHS program. There is a newsletter called The Catch that is really fun to read and gives you kind of those tips that you need and some really fun stories to talk about with the program. And then with our office, we have a quarterly newsletter that comes out and is available online that kind of gives you an overview of what happened over the last season, some fun maps for the outlook, and also more climate information as well. So those are available to get you more information of what has happened and some tips to get you ready for the upcoming season. So another thing with observers is when you sign up to be one, just keep in mind emails are really important and try to keep them current because we use them as a weather service to keep you updated on any upcoming training. And also if there's a big event coming that we want to get you ready for, we'll send those out as well. And also, when we are looking for updates, especially when it comes to snow water equivalent, we'll probably send that email out to you as well to get everybody on task to be giving those reports. And they're called SWE Mondays, Snow Water Equivalent Mondays. Typically, we send those reports once a week, and Mondays are usually a good day to do it. But if we have a big, heavy snowpack, we may be asking for more reports on that to be able to share that and help some of our users be aware of how much water is in the snow. So, how do you get started with this if you're new to the program? Well, you can sign up right on the CoCoRaHS website, CoCoRaHS.org. The other thing you need to have is a rain gauge. And not just any rain gauge, but a 4-inch rain gauge is preferred. And on that website gives you chances to be able to order one that you can use. So everybody's using the same type of rain gauge. There's some training slides available, but I'm going to step through some of this during this one training session right now. You also need to find a good spot to put your rain gauge. And then when it starts raining or snowing, you just start giving the reports. So with rain, like I mentioned, that's pretty straightforward. When the rain falls in the gauge, you read the line on the gauge and you report what liquid is in there. So yeah, it's very easy. With snow, it's a little more complicated. And like I said, we appreciate all the snow reports that we get from our observers. We look forward to getting those morning CoCoRaHS reports that come in after a big event because we tally them all up and we put them in our local storm reports and send them out to the media. But just want to let you know, and I'm sure you're aware of it for the current ones, is before that snow flies, we want to make sure your gauge is ready. So hopefully your 4-inch ray gauge is outside right now without the tube and without the funnel because we don't really use those when we're catching snow. You want to keep those inside and keep them safe, but you keep that big wide gauge outside to capture all of the snow. So I have a couple little videos to show you on how do we get ready for our snow measurement. So this is one that talks about getting ready for measuring snow. Now there's no audio to this. These links are available on the CoCoRaHS website, but I'm just going to talk you through this. So the tool that we need is that rain gauge. It's a 4-inch plastic rain gauge. Comes with an outer tube and an inner tube and then a funnel on top. So there's 3 parts to that rain gauge. Another important piece of equipment is a snowboard. Now, not something you take down the snow hill, but it's a board that is painted white and at least a foot by foot or 16 by 16 inches. And it's something that you're going to put on the snow to measure your new snow depth from. And the other important piece of equipment is a yardstick or a ruler that we can use to measure the snow. And then lastly is a snow swatter. Yes, it's a swatter. It looks a lot like a fly swatter, but it helps you knock down the snow from your gauge. So setting up for measuring snow. Okay, so you're going to have your gauge put somewhere in your yard that is away from objects and likely your snowboard as well. So not under a tree, not under the eaves. We want to have it away from anything that could hamper your snow measurement. So primarily in the middle of the yard. Also key is put a little flag or reflector by your snowboard because when the snow does fall, you want to know where that board is. Okay, so you're getting ready for the snow. You want to take that little tube out and the funnel and put it inside the house and just keep that outer tube and put it outside. And now you're ready and waiting for the snow. But it's okay. You can go do other things and everything is ready and you'll be prepared for when the snow does fall. So to review, what we need is a 4-inch rain gauge. You need a board, a snowboard that you put on the snow to measure that new snow that falls. A snow swatter that looks a lot like a fly swatter or maybe even a spatula. And then a ruler or a yardstick. Now, if you have a ruler that you're able to measure tenths of an inch, that is even better because we are able to provide new snow depth in tenths of an inch. If not, you're just going to have to round it to figure out what the accurate new snow depth is. Okay, so here are the 4 parts for measuring snow. And I told you, yeah, this is a little lengthy. So the first part we're going to talk about is that new snowfall. So the new snow that falls. And this is where you want to have your snowboard ready to go. So here's another little video that shows how to measure the new snow depth. Now remember, snowfall is the snow or ice that falls in a 24-hour period prior to melting or settling. So we all know when the snow falls, it's light and fluffy, and the ideal time to measure the snow depth is right when it ends, because after it kind of settles a bit. But knowing the time that it ended is also important as well. But we all know that we might be at work or away from home when the snow does end, but that's okay. You can still provide an estimate of when the snow ended, and you can measure your new snow when you are home. So on the form, there's an area called observation notes, which is a key area to put down on the time the snow started and the snow ended. So when you want to measure your snow, you're going to take your yardstick and find where your snowboard is and put it in and measure the snow. Now, keep in mind that we want to be at eye level so we know just as close as we can the accuracy of the snow depth. So you want to measure it from your board, but maybe you want to take other measurements as well, maybe from a picnic table or your patio, just so you have an average of how much snow has fallen. And once you measure that, you pull your board out, get the snow off, and then put it right on top of the snow. So you're ready for the next new snow measurement. And you put in that measurement right under that tab called New Snowfall. I know, pretty easy. So here are just some notes to review. Snowfall is new snow that's happened in the past 24 hours before melting or settling. And you want to use a ruler to measure the snow on a snowboard or a level spot in your yard that you have cleared away. So you can use a patio or sidewalk that you have shoveled away, or a picnic table, anything that's going to be somewhere that you cleared the old snow away that you can keep a good measurement of for the new. And try to measure the snowfall as soon as it stops. And also provide a time of when it started and when it ended. It's also important that you can put in that observation part of the form. And with new snowfall, you can report to the nearest tenth of an inch, which is key. And here's the form on the CoCoRaHS report form, and it's under the new snowfall right here that you put in that measurement. So that one is pretty easy. Now, the next measurement has to do with the liquid water equivalent of the new snow. So it's the liquid that fell in the snow. It can be from the gauge or what was on the board, because they should be very similar. So here is another little video short that talks about how to measure precipitation when it snows. So ideally, you want to take the snow from your rain gauge. So yes, you wake up, you see it's snowing, it's your reporting time to measure it. So you go to your gauge and you notice he has his snow swatter. So what that snow swatter is used for is to tamp down the snow on top of the gauge, especially if it's accumulated a little bit, so you can have an accurate snow reading in your gauge. So once you do that, you take that gauge and bring it inside. And what you need to do is melt that snow. Now, we don't really want to put it in the microwave or next to the heater, because that is just not wise. The best thing to do is to add warm water to the gauge and measure it out in your smaller inner tube. Keep in mind of how much liquid you add, because then there's going to be some math at the end to subtract that from the total. Because you add enough warm water to melt the snow, and then you subtract out how much warm water you added, and that gives you that daily precipitation. And then on your form, when you fill that out, that is the part where you put in the rain or melted snow. So that is the section that typically we always filled out, whether it's rain or now melted snow. That's where that number goes to. So here are the notes from that. This is the liquid snow measurement, or the liquid water equivalent. So you want to go outside and get that 4-inch gauge, bring it in, and you might have to swat some of the snow away. And then you take the smaller inner tube right here and use the measurements on the side to fill it up, so you have a measurement of how much warm water you're adding to the snow, enough to melt it down. And then you measure out all the liquid that's left to find out what the total is. And then from that total, you subtract out how much liquid water you added. So you do your little math and you get the number of what is left for your melted precipitation. So the water melted from the core goes right here. That's your precipitation, your daily 24-hour precipitation. But it also can be the melted core from the new snowfall as well. They should be one and the same right here. And also remember to add the notes of when the snow started and when it ended. Okay, the next step is called the total depth of the new and old snow at the time of the observation. So the total depth is the old and the new together. So here is a little video to kind of talk about what this is, new and old together. So we don't really need the rain gauge for this. We just go outside and you're walking in your yard and you take your yardstick with you and you're just taking measurements in your yard. And you might want to take multiple measurements so you get an average. We want to avoid drifts. we want to avoid anywhere that we piled snow up from shoveling or from plows. We want to find an average depth across our yard or our property. And if there's areas that the snow is melted, you want to include that as well in your percentages. So let's say half of the snow is gone, then we put that with our average so we can calculate how much is covered. And if it's less than an inch or a half of an inch, then it's a trace of snow that we can put for our snow depth. So to review for the total snow depth, that is the old and the new together. So we don't measure that from our snowboard. We just go out in our yard with the yardstick and start measuring in multiple stops. We're looking for the average depth of the snow, and that is on the ground at observation time. And the depth of the snow can be done in a flat portion of your yard away from drifts. And also include how much of your yard is not covered in snow as well. And with total snow depth, we do this measurement to the nearest half of an inch. Remember, the new snow was a tenth of an inch. With the snow depth, we go by halves. And on the CoCoRaHS form, it's under the total snow and ice on the ground section right here that we put in for the nearest half of an inch. So one more part to the observation. Number 4 is known as the snow water equivalent. And that is the amount of liquid of the total snow on the ground. Now, this is the SWE that I talked about. And typically, you don't have to do that every day because that can be very time consuming. But if you can do it weekly, that would be ideal to do. So to do this, you need to take your 4-inch gauge outside to your yard, your property, and do a core sample, which means that after you've done the measurement of what's ever in the gauge, you take that 4-inch gauge and take it out and put it into the snowbank and try to capture a core of the snow. With light snow events, it's a little more challenging. You might have to use your snow swatter to get all the snow in the gauge so you can bring it in. With the deeper, wetter snow, it's a little easier because you just kind of sink it down in and capture it in that tube. So once you get that snow in the 4-inch gauge, you bring it in, and just like you did with the daily precipitation, you got to melt it down. So to do that, we're going to add warm water that you've pre-measured in that inner tube to melt it down, and then take a total measurement of the liquid, but remember to subtract out that additional part that you added. Now, SWE measurements are very important, especially when we have a big, thick snowpack, letting us know how much water is in the snowpack. So that's why we usually look for those maybe once a week, ideally on Monday. And if there's a large snowpack across our region, we'll probably send out some emails reminding you that, hey, we're kind of curious on this. Can you give us that extra measurement? And that would be great. And that value goes on the CoCoRaHS report under the total snow, under the melted value from the core right here. So it is different than the new snowfall amount. So I'm sure you have some other questions having to do with CoCoRaHS and observing. So I put together some Post-it notes that I have all over my fridge to remind me of what to do under these conditions. So keep in mind when it's windy, your snow is going to blow around and you're going to have lots of drifting. And I know we have lots of areas that have to deal with this. Just keep in mind that you may have to take a core sample in a location that's more representative than what fell in your gauge. So maybe it missed your gauge altogether, but find a spot in your yard that you can do a measurement and get a good estimate of how much snow had fallen and the liquid from that. Now, even if there's no new precipitation, please send us a report because zeros are important. Yeah, that's right. They are important, especially if days and days of zeros. We like to hear from you. And it's really easy. Just click, submit with the zeros. But that gives us a good idea of where we have not seen precipitation in a while. Now, if heavy snow is falling, you can send in a storm report, and that is available through the web page option under CoCoRaHS that you can send in a heavy snow report. And if the snow is melting as it lands, keep in mind that is a trace of snow. So even if you see flurries in the air, when you send your report, it is a trace of snow for the next day. And you can add that in the comments as well. Okay, more notes. What happens if you run out of time? You got to get to work. How do you finish your snow report? Well, do what you can and put NA in the boxes if you can't finish it, and then just come back to it later in the day and fill in the rest of the notes. But do what you can and then send it, and you can always go back and edit the report later in the day. Oh, another good one having to do with freezing rain. So freezing rain is rain that falls, but the temperatures at the ground are below freezing, so it actually turns to ice. And we don't really have snow involved with this. Freezing rain is not snow. So whatever's in your gauge that's frozen, you want to bring it inside and melt it down. But when you fill in your report, you put in the liquid equivalent, but new snow is actually a 0. But for total snow depth, you can include the thickness of the ice on the ground. Yeah, it's a little confusing, but keep in mind it's not snowfall, but snow depth includes the ice thickness. Now, what happens if you're gone for a few days? You go on vacation, especially over the holidays. It's okay. There's an option that you can send a multi-day report. So once you come back, you can send in a full report of while you're gone of how much snow fell was in your gauge that you melted down, and that works as well. So CoCoRaHS is one of many different volunteer programs we have through the National Weather Service that provides us valuable data. So it's the one in the middle, and CoCoRaHS provides gives us observations of precipitation, whether it's rain or snow or hail. And there is a rain gauge that is required to give this information. It is a daily commitment to do this, and there's a very easy to use website that you can get a lot of information from and send your reports to. Now, the other two programs we have available as well. One is this Weather Spotter program, and we've been doing those classes this fall as well. That is more of a easier type of volunteer program to do. You're just reporting severe weather or hazardous weather, and it's all event driven. So that's an easy one to step into. And the CWAP program, that's for those that have a weather station on their property and you have it hooked up to a computer that you're getting the data all flowing. Well, we encourage you to share that data online so the weather forecasters can use that as well. So just a review for the other programs. For the Weather Spotter program, it's a weather enthusiast who will report severe and hazardous weather. And it's an as-needed basis, no equipment needed. You just call us, email, report online. And if you are not a weather spotter and are interested, just email us right here and let us know, and we can get you signed up for that program. Now, those of you that have a weather station on your property, and you have it hooked up through your computer and online, feel free to share that information with the weather forecasters, especially our office as well. And you can go. This is called the CWOP program, the Citizen Weather Observer Program. And this way to register is wxqa.com. I know there's other ways that you can share that data also through Weather Underground as well. There are different ways that you can get your weather station right online, and we're able to use that as well. So, want to point out the CoCoRaHS.org website has lots of additional training on there and notes and videos as well. Okay, so now we're going to talk about some typical winter type scenarios. What brings us all of our different types of snow and rain and wintry weather? Now, their typical type of scenario is where we have cold air in place, very similar to what we have right now. And we get a warm Pacific storm system that is approaching the Washington coast. And we see this warm air starting to ride up into the region. And then we get the clouds moving in and then precipitation falling. And we can see quite an array or range of precipitation in our area based on what the temperatures are doing. So the temperatures are key on what type of precipitation is falling. Temperatures not only at the ground level, but all the way through the vertical profile of the atmosphere. So where we have the cloud bases, in the wintertime, typically the precipitation is falling as snow. It's already below freezing. But if we get a warm wedge of air that moves in, that thickness of that warm wedge will give us different types of precipitation. With a very thick wedge of warm air that's all the way down to the ground, that gives us our rain. So we see those snowflakes falling, turning to rain as it moves into that warmer air, and then falling as rain. Now, it'll change as that warm wedge of air gets more shallow. So when we have that warm air moving in, but our surface temperatures are still below freezing, we will get the rain falling, but it turns to ice once it hits. And that is called freezing rain and very treacherous to drive through. Very dangerous conditions. Now, as that wedge of warm air gets even shallower, we'll get the snow turning to rain, but then refreezing, but then falling as sleet. So it's frozen precipitation that falls as little ice balls that comes down to the ground. And then when we don't have any wedge of warm air, those snowflakes are just going to fall straight down to the ground as snow. So here are some examples of different types of precipitation. Here's one that talks about the sleet. So the sleet are those frozen balls of ice that are rain that refreezes. But the other two, I mean, they look very similar, but they're not because they are different processes that cause these. Now, the one in the middle is called graupel. And graupel is something that we see from more convective showers that happens in the late winter, early spring when we get the showers popping up. And it looks like it should be just a light rain showers, but it's white and it falls as a little soft hail that comes down. So this would be like little styrofoam balls that fall down and hit the ground. Compared to hail. So this is pea-sized hail over to the right, and this falls from more thunderstorms. So bigger storms that fall that happen in the spring and into the summertime, and they are solid pieces of ice that fall down and reach the ground. So I know different types of precipitation, they look different but have different processes. Okay, another type of topic that we get in our winter season are called atmospheric rivers. These are plumes of atmospheric moisture that come from the subtropics and accompany a strong jet stream and area of low pressure, and usually brings us mild and wet weather. So if we've had snow on the ground, we get one of these coming in, and our snow is going to turn to rain, and our snow levels are going to rise up to the mountain peaks, and we're going to get a lot of rain with that. So with this, these are when we get our flood events that are happening that lead to mudslides and rock slides and flooding that happens in a lot of our low-lying areas. And also ice jams happen with that as well as we warm up so rapidly and we get some of the ice breaking up. So it can lead to a lot of precipitation in a short amount of time. And just a year ago in November is where we had one of these atmospheric rivers that hit the west side of Washington. We had some of the effects of it, but what was really key is that several of our main rivers, including the Stehekin, the Okanagan, and the Similkameen, they got the heavy rain in their headwaters. So all that water came running down these river basins and caused flooding in parts of north central Washington, where the precipitation wasn't really that dramatic, but all of that water fell in the headwaters and led to flooding downstream. Another type of scenario is where we get a big upper level low over us with lots of cold air aloft. And this happens behind strong cold fronts. And we may get some showers that start rotating and producing bursts of heavy snow. These may be hard for our weather models to pick up, but it can lead to potential of a foot of snow in a short amount of time. And we've seen these time and time again, not only in Spokane, but even in Wenatchee last year when we had these events that do happen. And these can lead to snow squall events. And this is a term that we're going to be hearing more about in the coming seasons because now we have developed a snow squall warning that goes out when we get this. Think of it as an intense burst of snow that's just a couple hours long that leads to whiteout conditions. So not really a blizzard. It's kind of a short fuse type of event and can lead to treacherous road conditions. So this is something that we were going to want to get more reports on with these types of events that happen that really can lead to dangerous road conditions. Now, overall, as observers, we have to stress the importance of safety, especially with all types of weather hazards. Just remember to be safe, protect yourself, protect your family. Don't go out and search for extreme weather or go out there in the flooded waters to get a rainfall report. It's not worth your lives and your safety on that. So please be aware of that and stay safe. We don't want to have any weather observers getting stuck in the storm trying to get us an accurate report. So ways to keep you informed. Well, number one, want to stress our webpage at weather.gov/Spokane. We have a wealth of information on there. We have our weather stories that are going to kind of give you the highlights of what to expect in the coming week. We have our point and click forecast that you can click on and get a detailed forecast for your location. And it also highlights where we have any watches and warnings across the area. Now, for those of you that want to get your weather information on your phone, you can go to mobile.weather.gov and you can get that right from your phone. Now, the Weather Service doesn't have an app right now. So we use this site to put in your location, and then you'll get the forecast popping up on your phone, and then you can simply add the website to your home screen for quick access. It will give you a little widget right here on your phone that you can go back to get the latest forecast. And it's a slick way of keeping informed right from your smartphone. Also, keep in mind on your phone, we have alert capabilities, especially for extreme weather and water warnings. There's a section on your phone for local emergencies, and I hope you keep that turned on just in case one of them does strike. It's in the same section for the amber alerts. But for these extreme weather and water warnings, this includes the capability of being alerted through wireless emergency alerts. So if you're within the polygon of this warning, your phone is going to go off. And this includes for tornado warnings, flash flood warnings, extreme wind warnings, dust storm warnings, and yes, even the new snow squall warnings. So if you're within these polygons for these warnings, your phone will go off and let you know. It's also very important to be prepared. We're into winter. We're in the inland Northwest. It's important to have our vehicles winterized. Get the snow scraper in there if it's not in there. Throw some extra blankets, gloves, hats, maybe a little shovel in there as well in case you got to dig out if you're stuck in the snow. But also at home as well. Know where your flashlights are. Know where your batteries are. Keep the flashlights ready to go. Have your cords for your devices ready so you can plug them in and be ready before any power outages do happen. And stock up with food and water and have everything ready to go so you're prepared when the big weather event happens. So I also want to point out on the CoCoRaHS website, there's a lot of other ways that you can learn more about precipitation reports, about drought and the lack of precipitation. There's also a great section called Weather Talk where they have weather guests and meteorologists that talk about different topics. So you can learn a lot about different types of precipitation users and share some of that information as well. Another pretty fascinating thing about CoCoRaHS observers is after 100 reports, your site becomes a climate site. I know that's pretty fascinating. And there are water year reports that are available every year. This is the first climate record season that they included CoCoRaHS observers in the normal. So every 30 years, well, actually every 10 years, the normals for an area get updated for the last 30 years. So in this last update that happened last year, they pulled in CoCoRaHS observers as part of the climate record. So that is that's pretty exciting to know that our volunteer records are making an impact on that. Okay, so last thing we're going to talk about is the winter outlook for 2022 and 2023. But first, let's look back what happened last water year. So water years start with precipitation that falls from October 1 to September 30th. So that way we can capture the entire winter season along with the spring and summer. And typically fall is pretty dry. So that's why we do the cutoff from October 1 to September 30th. So if we look back in the last year, generally not too bad. Where we see the oranges and yellows, that means it was below 100%. So, parts of Grant County, Douglas County, a little bit of Stevens County, we had some pockets that were a little on the dry side, but for the most part, the Southern Columbia Basin looks like south and east of Spokane and the Idaho Panhandle fared quite well, and also Okanagan County and parts of Chelan County as well. So that was all some very good news. Now, since we have started the new water year, how have things been trending? Well, the map on the left shows the average temperatures. And I know we're starting a little bit before October 1st, but it kind of gives you over the last 60 days. Temperatures have actually been trending warmer than normal. Well, if you remember, September, October were so mild. Oh, well above normal. It was the fall that just didn't end until we got to November. And then we have been put in the freezer a little bit. But still, over the last 60 days, we've been trending above normal region wide. Looking at precipitation, we still see that dry wedge that stretches from Grant County, Douglas County, into parts of Ponderay and Stevens County. So still a little bit of a lack of precipitation in that area. But if we go to Southeast Washington, it's done well. Much of the Panhandle has, and even for North Central Washington. So how has this impacted our drought? If we remember a year ago, we were struggling to get precipitation to overcome how dry we were in 2021. Well, looking at the precipitation amounts, we've recovered quite a bit, especially from our cold and wet spring from this last year and into the first part of the summer. Things were still on the wet side, but our fall was dry, and it's kind of shown up a little bit on the drought update, the U.S. Drought Monitor, where we have some moderate drought still lingering. The Columbia Basin, it's been there this whole year. It's never really improved from that. But parts of the northern mountains have been a little bit on the dry side, and also on the west side as well. They had a dry summer and fall as well. But the seasonal outlook does show that improvement is expected, and drought removal is likely across much of the region. And why is that? Well, the pattern we're going to be into for this winter season is La Nina again. Yes, La Nina is still here, and that has to do with the cooler ocean sea surface temperatures that are happening near the equator across the Pacific. And this is the area. Here's South America over here, and here's Indonesia. And we have a big swath of cooler than normal ocean temperatures. And we know that the ocean temperatures do have a lot to do with our atmospheric pattern. And what that tends to do is bring us more of a unsettled pattern into the Pacific Northwest. So we're seeing these La Nina conditions are going to persist through this winter, through February 2023 in the Northern Hemisphere. And here's the seasonal outlook, and those blue bars are showing La Nina, strong confidence happening all the way into January, February, March. And then we start seeing a better tendency of seeing things kind of decreasing for La Nina, but getting more into a neutral type of pattern as we get into this spring and summer. So with La Nina, as I mentioned, it does those cooler sea surface temperatures impacts our atmospheric pattern. So what that brings us is a polar jet stream that is variable, but it tends to swing down from the Aleutians down across British Columbia and into the Pacific Northwest. And depending on what side of the jet we're on, it gives us either a wetter pattern or a windy, colder pattern. So it can vary as where that jet stream comes through, but it does bring us lots of storms coming from the west northwest. And another key thing to keep in mind is this is the third La Nina in a row. So we had La Nina last year and the year before that. So one thing we know about La Ninas is they tend to bring us above normal precipitation and below normal temperature, especially for the latter part of the winter season. So it's not surprising that we see our climatology for snow being typically above 100% for La Nina. So here is some sites across our area and the percentages of snow compared to normal. Spokane, we usually see 123% of normal for snow. Sandpoint, up to 116% of normal. If we go down to Pullman, about 128% of normal. And we have a link right here from our webpage that you can check out some of these locations for yourself and see what the differences are for many sites across inland Northwest. So, for example, here's Spokane. So for a La Nina year, first of all, this red line will show what the average snow is. And for Spokane, just over 48 inches. Under a La Nina year, we see on average just shy of 60 inches of snow that happens. Now, comparing that to an El Nino, opposite conditions, we tend to get drier and warmer types of winters with that, and not surprising, about 35 inches of snow. And neutral years, they're pretty close to average that happen. And here's another comparison for Pullman. So on average, they see about 36 inches of snow a year. With La Nina year, that boosts it up to maybe 46 inches of snow. Compared to a La Nina, that's maybe closer to 24 inches. And neutral year, very close to average. So with the different patterns, we can have different snow amounts. And like I pointed out, this is going to be our triple dipper, 3 years in a row of a La Nina. And going back to 1950, this has only happened 2 other times. So the winter of 2000 and 2001 was a third La Nina in a row, and also 1975 to 1976 one as well. So let's look at the long range outlooks. First, we're going to start with the midterm. So 8 to 14 day outlook. So this will close out pretty much the rest of November. And as we get into the busy Thanksgiving holiday, not surprising, it's been cold, it's been dry the last couple of weeks, but we're going to see the pattern switch where temperatures are going to be warming above normal, but then precipitation chances are also going to be on the increase. So we're going to see more active weather coming by next week, just in time for our Thanksgiving holiday. Now, we don't have anything out for just December, but if we look at the season as a whole, December through February, we see that pattern looking very La Nina-like, that temperatures are going to be trending below normal across the entire region and even the northern tier states for temperatures. And precipitation, a really strong La Nina signal with that, with above normal precipitation across the entire region. And that goes from December, January, and February. So, key points for our winter outlook. La Nina is still here and will continue through the winter. And the outlook favors elevated odds of cooler and wetter and snowier than normal across the region. Another thing, winter arrived early. We've been cold, we had our snow, and anticipate more of these to happen. More snow, ice, rain, wind. But also keep in mind, one storm does not make a season. Remember that the seasonal outlook is the average over the whole periods. And we may have some really heavy snow events. So that's why we need your reports to help us with this upcoming season. So we really do look forward to your reports. So that pretty much wraps things up for us. And I want to thank you for joining us. I really appreciate you spending the evening with me. So what's next? So for those of you that are still CoCoRaHS reporters, observers, nothing much. Just continue what you're doing and work on your snow measurements. I know I always need a refresher as well. If you're new to the program and want to join in, Just go to that CoCoRaHS.org website and you can learn more, register, see some more slides and trainings, but check out those maps. They're pretty neat that you can see the precipitation amounts and the snow amounts. And also, I'll be following up with an email and send you some links and other information as well. So, with that, I am going to